Okay, let's look at the action potential. The action potential of cardiac muscle is different from the action potential of a skeletal muscle. First, let's look at the action potential for a skeletal muscle. You're going to have depolarization, repolarization, hyperpolarization, and then you will have return of the resting membrane potential, if you remember that from A&P1. This is something like 1 to 2 milliseconds. So it's extremely fast. Okay, let's look and see how this would compare to the action potential of cardiac muscle. You would have depolarization, a long plateau phase, repolarization, and then it would return to the resting membrane potential. Okay, the refractory period for the action potential of cardiac muscle cells is 200 to 250 milliseconds. So you can see that it's much longer. Okay, if you actually drew this out, you would have to write all along the walls and everything to get the length of the action potential. So what happens is we take out part of the action potential, put this bracket in to show you that we have cut part of it out so that it's not going to be quite as small as what we've made it out to be. So let me erase that. Okay, we want to look at the ions that are responsible for the action potential. Okay, a couple of them are the same as what they were in skeletal muscle. The ion responsible for depolarization, if you remember, depolarization is this upward swing. This is going to be sodium moving into the cell. Remember, here's your normal cell here. Your sodium's on the outside. So sodium will be moving in, and that's going to be depolarization. Okay. Then you have another ion that you didn't talk that much about last semester. It's calcium. Calcium is going to be located outside of the cell. That's our new ion for our action potential. And these gates for calcium are going to open really slow. So calcium goes in slowly. It takes a while for calcium to enter the cell, and that's the reason that you have this long plateau phase over here. So this long plateau phase is because of calcium. Calcium taking so long to enter the cell. And then we had another ion that was responsible for repolarization. And repolarization is going to be because of potassium moving out of the cell. Potassium moves out of the cell. So here we have repolarization in our downward swing, and it's because of potassium moving out. Okay, the same way you would have it in skeletal muscle, you have your sodium-potassium pump kick on, and that's going to cause sodium and potassium to move. Calcium would also be pushed out. That would be in our hyperpolarization, and that is going to return our cell back to the resting membrane potential so that it's ready for another action potential.